Today we're going to talk about an alternative way for finding the vertex of a quadratic. We already know how to do it by a process called completing the square, so let's just review that real quickly. We're going to bump the -7 out of the way, so we get x squared plus 6x, put your -7 over here. And then remember, we take the 6 here and divide it by 2. 6 divided by 2 is 3. And 3 squared is 9. So we put our 9 there, and then remember you have to put -9 on the over here by the -7, and in effect we've added 0 to the quadratic, so we've not changed it really in any way. This part is a perfect square trinomial which factors into x plus 3 squared, and then -7 take away 9, that's -16, and our vertex then is -3, -16. So that's the old way, called completing the square. There is another way to handle the same process, or the same question with a slightly different process. And that involves a formula. And for that, the axis of symmetry is found with this equation. X equals the opposite of B over 2 times A. And if you look back up in this original quadratic, A was 1 because the lead coefficient is 1, B is 6, and C is -7. So if we plug these numbers into this, we get x equals the opposite of 6 divided by 2 times 1. And so that's -6 divided by 2, which is -3. So we get an x value of -3. Notice that's the same thing we got earlier when we completed the square. The next thing we need is we need the y value of the vertex. To find the y value of the vertex, we just evaluate the original function when x is -3. So everywhere I see an x, I put a -3 in there. So that'll be -3 squared plus 6 times -3, take away 7. So -3 squared, remember that's a +9. 6 times -3 is -18. And now we got 9 minus 18 minus 7. 9 minus 18 is -9, and -9 minus 7 is -16. So the x-coordinate of the vertex is -3, the y-coordinate of the vertex is -16, so indeed the vertex is -3, -16, the same thing we got by completing the square. Now for our next example, I've got a slightly more complicated quadratic. I've got -3x squared plus 5x minus 6. And if you can imagine completing the square, it might get a little bit messy because we're going to have to factor this -3 out of this 5, and it'll get kind of ugly. So that's where this newer process comes in handy. The axis of symmetry is found using this equation. X equals the opposite of B over 2 times A. So our B value is 5, so the opposite of 5 is -5. Over 2 times A, and A was -3. So then we've got -5 divided by -6, which is just 5/6. So the vertex has an x-coordinate of almost 1, 5/6. To find the y-coordinate, take my function f and substitute 5/6. So I'm going to take -3 times 5/6 squared plus 5 times 5/6, take away 6. And if you've got your TI calculator, you could just type this in right there as you see it, and it'll give you a nice decimal answer. But what the heck, let's go ahead and do the math. If I square 5/6, I get 25/36, which I am multiplying by -3. And then I have 5 times 5/6, which is 25 over 6. Take away 6. Now I'm multiplying this fraction by -3, so the numerators I multiply, so that's going to be negative 75 over 36 plus 25 over 6, take away 6 over 1. And it might be helpful to get a common denominator here. I've got a denominator of 36, a denominator of 6, and a denominator of 1. So if I were going to get a common denominator, I might want to go ahead and use 36 as that denominator. So I'm going to use some middle school methods here and convert this fraction to a fraction with a denominator of 36 and do the same here. So this one I'm going to multiply by 36 over 36. This one I'm going to multiply by 6 over 6. So now I get negative 75 over 36 plus 150 over 36, take away 216 over 36. So now I have a common denominator. I can write that common denominator and then take negative 75 plus 150 minus 216, and that is negative 141. So if I wanted my vertex as a fraction, that would be the y value of it. So I could write negative 141 over 36. And then I could also use my calculator and say, hey, the x value is 5/6 and the y value is about negative 3.917 if I'm rounding. I hope you enjoyed that. Thanks for watching.